These notes are going to go over how to solve limiting reactant problems using stoichiometry. So I'm going to let you read the first paragraph on your own, but I'm going to do the example problem to show you how you might go about solving one of these. Now, there's more than one way to solve a limiting reactant problem. I'm going to show you one way that I feel is pretty straightforward. If you want to learn about alternative ways to solve limiting reactant problems, feel free to ask me during class sometime. So the first thing I'm going to do is I'm going to balance the chemical equation, because to use stoichiometry you need a balanced recipe or a balanced chemical equation. So in this case, I'm going to use the coefficient 2 over here to balance my aluminums, and then I'm going to use the coefficient 3 here to balance my oxygen, and then I'll use a coefficient here to balance my iron. And so this will be my balanced chemical equation. Now in this problem, you're given two reactants, 100 grams of aluminum oxide and 50 grams of iron. And it's asking you theoretically how much aluminum can be produced. So this is a lot like our s'mores lab. I've got marshmallows, I've got chocolate. How many s'mores can I make? So in this case, I'm going to basically break this up into two parts, two problems. So I'm going to say problem number 1, problem number 2. In problem number 1, I'm going to see how many grams of aluminum can I make with my aluminum oxide first. So I'm going to start with my 100 grams of aluminum oxide, and I'm going to convert that into grams of aluminum. So if I had 100 grams of aluminum oxide, I know that every 1 mole of this is 101.96 grams. That's its molar mass. I use the periodic table to find that. And then I'm going to cross my mole bridge, and I know that for every 2 moles of aluminum, I use just 1 mole of aluminum oxide. So 1 mole of aluminum oxide for every 2 moles of aluminum. That's going to put me into the unit of aluminum, moles of aluminum, and then technically, I could stop there and know which one's my limiting reactant, but the question's asking me how many grams of aluminum. So I'm just going to go all the way to grams. And I know that for every 1 mole of aluminum, that's going to weigh 26.98 grams. Moles will cancel, and I'll be in grams of aluminum. So if I had 100 grams of aluminum oxide, I could theoretically make 52.9 grams of aluminum. So now I'm going to do the second reactant, and I've got 50 grams of it. So I'm going to do the same thing with iron. How many grams of aluminum could I make with 50 grams of iron? So I'll start with getting out of grams and into the mole. So I know that every 1 mole of iron is 55.85 grams. And then I want to know how much aluminum that will make. So I know that for every, in this case, 3 moles of iron, I can make 2 moles of aluminum. Right? That's from my balanced chemical equation. And then again, I'm going to take that final step and go to grams. Every 1 mole of aluminum is 26.98 grams. Let's see, moles of iron cancel, moles of aluminum cancel, and then when I solve it, again, I'll be in grams of aluminum, and this is going to work out to be 16.1 grams. Now what I'm going to do is I'm going to compare these two numbers. So if I gave you both of these, right, I'm going to run out of one of them. And so what's going to happen is I'm going to run out of iron first. So from this information, I can tell that I am going to run out of iron once I theoretically make 16.1 grams of aluminum. So I theoretically think I can make 16.1 grams of aluminum. At that point, I will run out of iron. When you run out of iron, the reaction stops and you can't make any more aluminum. So you can't make all of this aluminum appear. So if you can't make all of that, that tells me a couple of things. It tells me, number one, that my aluminum oxide is going to be my reactant in excess. I'm going to write Re. So my aluminum oxide is my reactant in excess. My iron, in this case, is going to be the thing that limits the amount of product I can make. So then this becomes my limiting reactant. So my iron is my limiting reactant, and my aluminum oxide is my reactant in excess. All right, so theoretically, I think I'm going to make 16.1 grams of aluminum. All right, so then I've already solved the step 2. I already know that I think I'm going to make 16.1 grams of aluminum. Now the next question is asking me how many grams of reactant in excess will be left over. So I know that my reactant in excess is the Al2O3. I know that my limiting reactant was the Fe. So that means I know that I'm going to use all of this. All of this. So that's going to tell me how much aluminum oxide I'm going to eventually use. So again, it's a lot like the chocolate and the marshmallows. If you only have 10 marshmallows, you can only use 30 pieces of chocolate. Same idea. So I know I'm going to use all of this. So that's the number I'm going to start with. I'm going to start with my given of 50.0 grams of iron because I know I'm going to use all of that iron. And I'm going to figure out how many grams of aluminum oxide I'm actually going to use. So all of this is used. So I'm going to write used next to it just so that I can keep it straight while I'm working. And I'm going to go all the way to grams of aluminum oxide. So I know that every 1 mole of iron is 55.85 grams. Again, grams cancels. I'm in moles. This is how many moles of iron that I'm using. And then this time I'm going to go to aluminum oxide because I want to know how much aluminum oxide I'm using. So I'm going to look at my balanced chemical equation. I see that I use 1 mole of aluminum oxide for every 3 moles of iron. So 1 mole of aluminum oxide for every 3 moles of iron. And then I'm going to do that one last step and go into grams. So I know that every 1 mole of aluminum oxide is 101.96 grams. And then when I finish all that stoichiometry, it'll tell me how many grams of aluminum oxide I've used. So in this case, I'll do all of my math and I get 30.4 grams of aluminum oxide that's used. Now that's really important because our next step is going to figure out how much I have left over. So that's going to be, again, a lot like your s'mores. So if I had 10 marshmallows and I only used 30 pieces of chocolate, but I gave you 60, there would be 30 left over. So in this case, I'm going to go back up to my original problem. I gave you 100 grams of aluminum oxide. So I gave 100 grams of aluminum oxide. You've used 30.4 grams of aluminum oxide. And then if you do the math, you'll see that you have 69.6 grams of aluminum oxide left over. And then technically, if we're doing sig figs, you get no places after the decimal, so I would round it to 70 grams of aluminum oxide left over. So that's how you would solve a limiting reactant problem. What I'd like you to do is go ahead and try the next couple problems using the same format. Again, there are alternative ways of solving these limiting reactant problems, and if you'd like to know what they are, feel free to reach out to me.